solving a system of equations using the elimination method. Today what we're going to do is we are going to use the elimination again. However, when you first look at the problem, like example number one of the variables isn't eliminated right away. Meaning when we go to add these two equations together, this one doesn't drop out, the x's don't cancel, and -9 plus -9 is -18, so they don't cancel either. If we were to add these two together, we would have this in our answer. So what we have to do is we have to look for a variable that could easily be canceled, okay? So if I look at this problem, I'm looking at the y variable because -9 and -9, if we were to change one of those to a positive, the other one would drop out. So if this was really a +9, then when I add them together, the y's would drop out. If this was a +9, then when I add them together, the y's would drop out. So what we're going to do is whenever you see a problem like this and one of the variables doesn't easily drop out, what happens if the variables do not cancel? You are going to multiply one of the equations or both of the equations. Sometimes we need to multiply both of the equations by a constant, okay? A constant is just a number that does not change. So in this problem number one, I'm going to multiply the entire top equation by a -1. That's a constant, -1, right? And as long as I do it to the entire equation, it does not change the value of the equation. So I'm going to rewrite the top equation by distributing this negative through to each term. So I end up with positive 2x plus 9y equals positive 25. Then I'm going to rewrite this bottom equation just as it is. So that one's not going to change. So I get negative 4x minus 9y equals negative 23. Now we're right at that spot where we were yesterday, where if I go to add these two equations together, this negative 9y and positive 9y are going to cancel out. So I'm left with negative 2x, these cancel, equals 2. I'm going to divide by negative 2, and I'm left with x equals -1. Then I'm going to rewrite my original equation, so kind of keeping that 3-column method going that we talked about yesterday. I'm going to rewrite my original equation, negative 2x minus 9y equals negative 25, and I'm going to substitute in an x value right here of -1. So this x is going to go right here. So I'm left with -2 times -1 minus 9y equals -25. So now I'm left with positive 2 minus 9y. And now we're just solving for y. So I'm subtracting the 2 over. Negative 9y equals -27, dividing by -9. And I get y equals 3. That tells me that my points, if I were to graph these two lines on a coordinate plane, they would intersect at the point -1, 3. So that is my answer. That is what you have to make sure you write down on the test or quiz. That is what you're trying to find with the system of equations. Now, the third column is just our check. So we're going to rewrite now. We already used the first equation here. So we're going to rewrite this second equation for our check. So I'm going to write down negative 4x minus 9y equals -23. And then I'm going to substitute each value that I found right here into the problem. So -1 minus 9 times 3 equals -23. So I get 4 minus 27 equals -23. -23 equals -23, and it checks. So my answer of -13 is correct. Let's look at another example. This problem here, number 2, if you look, you're going to try and eliminate the y's. So we could multiply either the top equation by -1, or if you wanted to, you could multiply the bottom equation by -1 because it really does not matter. Either one of those is going to give you a -2y in here, and eventually they will be canceled. Okay? But let's look down at the third example. the third example is a little bit different. The third example, we do not have a variable that has the same coefficient. This one, they both have a coefficient of 2 on the y, so my I kind of automatically is drawn to that y variable. If we look down at number 3, we have a coefficient of 5 and 10, and then we have a coefficient of 1 and -7. So neither one of those is the same. But all we have to remember is that we have to multiply by a constant. So it doesn't necessarily need to be a -1. If I multiply this equation here by a -2, then this would give me a -10, and then this is a +10, and they would cancel out. I could also look at the y variables and say, well, I could multiply this entire equation by 7. Then when I distribute through and through, this right here is going to become +7y. This is -7y, and then they cancel out. So there's really no wrong answer here, wrong choice rather, that you can use as long as you get those two variables to cancel. We either need the x's to drop out or the y's to drop out. Because I have the 7 here, I'm just going to go with that method right now. So we're going to distribute through the 7. 7 times 5. Let's distribute it through. Is 35x plus 7y equals 63. And then I have 10x minus 7y equals -18. That bottom equation is not changing. Okay, it's just remaining the same. Now I'm going to go and add these two together. And I'm left with 45x equals 45. So then I'm going to divide each by 45. And I get x equals 1. So there's the first part of my coordinate there. 1, comma, something. So now we're going to go back. We're going to take the original equation. We're going to write down 5x plus y equals 9. But now we know our x from down here is 1. So we're going to come up here and plug in the x of 1. So 5 times 1 plus y equals 9. 5 plus y equals 9. Subtract 5 from both sides. And the y equals 4. So now I can substitute my y back in here. So my coordinate is 1, comma, 4. Now, just to check our work and make sure we have the right answer, you always want to check these. We're going to substitute into this second equation here. So we have 10x minus 7y equals -18. So I'm going to have 10 times 1 minus 7 times 4 equals -18. I'm taking those values, this 1 and this 4, from right here, from our answer. Okay? So we have 10 minus 28 equals -18. -18 equals -18. And there we go. Check. Your answer is done. Okay, time to do your worksheet and show me what you learned. Bye.